now I will be the Monty Python now for something completely different, because we're going to jump into the oceans in just a second. The one thing I want to emphasize is we live on a water planet, and we don't actually have much data about the water part of this planet. And it's just a statement of fact that the oceans are changing in our lifetime. And I'll give you some examples. And that will have profound implications of life on this planet, and there will be winners and there will be losers. So a good example that's very visceral that we all appreciate is the Arctic ice cap. Here's the annual sea ice minimum in 1980. Here's what it looks like in 2007, and it is rapidly melting. And by the time I retire, there will not be an Arctic ice cap. And this isn't just a professor, saying this. This is the Joint Chiefs of Staff in the Department of Defense. It's number 3 on their most critical issues, because climate change and shifts in the environment like this will destabilize countries. So my part of the game has been to study the ocean. The ocean is essentially the lungs of the planet and regulates the climate. So there's a strong interaction with the atmosphere, there's a strong interaction with the land, there's lots of arrows. Unfortunately, to understand the ocean, you have to understand how all these arrows interconnect, which require data that we don't currently have. What we've begun to appreciate is the surface ocean essentially fuels carbon down to the sediments. It's the largest carbon reserve on the planet. And most of the microscopic plants that grew 250 million years ago is the basis of all the petroleum we're burning now. So it took the Earth 200 million years to make the oil that it's taken us 200 years of industrialization to use. There's also an amazing amount of undiscovered life. Just a decade ago, they discovered in hydrothermal volcanic vents bacteria that can live at 120 degrees in boiling water, and they live within the rocks. And has huge implications for biopharmaceuticals. And so we have this undiscovered planet to go forth and do work. Unfortunately, if you're an oceanographer, the first thing you realize is the ocean is a really challenging and hard place to work. You get seasick. There's lots of storms. You don't work in storms. And I was trained the classical way, which is like this. And when you do go in storms, you break bones. And while this is a joke, it's really not. If you go out on a state-of-the-art research vessel, it moves about the speed of a 10-speed bike. And if you're studying biology, you might only be able to collect, in the traditional way, 12